Hello friends, this is Unit 4, Design Engineering. Here are the design concepts in that abstraction, architecture, patterns, modularity, hiding, functional independency, and refactoring. First one is abstraction, ability to scope up with the complexity. There are three levels of abstraction. At higher level of abstraction, the solution is stated in a broad terms using the language of the problem environment, while at the lower level of abstraction, more detailed description of the solution is given. Data abstraction describes the collection of data that describes a data objects. Procedural abstraction, named sequence of instructions in the specific function, that is, only the name of the functionality is given and all implementation details are hidden. For example, search the record is the procedural abstraction in which implementation details are hidden, that is, enter a name, compare each record with the name to be searched. If match is found, then declare success, otherwise declare name not found. Data abstraction. In this, collection of data objects is represented. For example, for the procedure search, the data abstraction will be record, which may contain record ID, name, address, and designation. Here are the data abstraction, procedural abstraction. Second one is architecture, is a representation of overall structure of an integrated system. Various system elements like components, object, functions interacts with each other by using the data attributes. Various system models are used in the architecture. First one is structural model. Overall architecture of the system is represented. Second, framework model shows architectural framework and corresponding applicability. Dynamic model shows reflection of changes on the system due to external events. And process model, sequence of processes and their functioning is represented. Fifth one is functional model. Functional hierarchy is represented. Third one is pattern, where design solution for a particular problem. In the design pattern template, pattern name describes the essence of the pattern in a short but expressive name. Intent describes the pattern and what it does. Motivation provides an example of the problem. Applicability notes specific design situation in which the pattern is applicable. And structure describes the classes that are required to implement the pattern. Patterns can be reusable, used for current work, used to solve similar kind of problems. Fourth one is modularity. Software is divided into separately named and addressable components called as a modules. This leads to divide and conquer strategy. Modularity, dividing a problem into manageable number of pieces. While developing the software, over modularity and under modularity must be avoided. Modularity should be such that development can be planned easily. Software increments can be defined and delivered. Changes can be more easily accommodated. long-term maintenance can be carried out effectively. These are the sizing modules, two views, that is what's the inside and how big is it. Modularity trade-offs, what is the right number of modules for a specific software design. By using this graph we can easily understand. Fifth one is information hiding, where using the diagram we can understand why information hiding. Modules are designed in such a way that information contained in one module can be accessible to other module. Sixth one is functional independence, where functional independence is achieved by developing modules with single-minded function and by avoiding dependency and excessive interaction with other modules. Functional independency is assessed using two quality criteria. Functional independence. Functional independence is achieved by developing modules with a single-minded function and by avoiding dependency and excessive interaction with other modules. Functional independency is assessed using two quality criteria. Cohesion is the extension of the concept of information hiding. Elements within the same module are connected or working together to execute that module. Stated simply, a cohesive module should do just one thing. These are the diagrams where here design principle, coupling and cohesion. Coupling means how modules are connected with other modules or with the outside world. And cohesion means for the elements that are within the module, the level of their interdependability is defined by cohesion. It is considered that the program design is better when the rate of cohesion is high. These are the types of cohesion. Coincidental cohesion, where when modularization is practiced without any planning, it is not preferred by the programmers as there are chances of cohesion confusing the programmers. Logical cohesion, when modularization is practiced on the basis of certain logic and the elements in a particular module are made together based on that logic, such cohesion is known as the logical cohesion. Seventh factor is refactoring, where process of changing a software system in such a way that the external behavior of design do not get changed. However, the internal structure get improved, that is simplifying the design without changing the function or behavior. Refactoring, that means when software is refactored, the existing design is examined for redundancy, unused design elements, inefficient or unnecessary algorithms, poorly constructed or inappropriate data structures, or any other design failure that can be corrected to yield a better design. Thanks for watching the video.